So we're talking about different pieces of triangles, such as medians, altitudes, angle bisectors, and perpendicular bisectors. So a median, the first one we're going to talk about, is a line segment that passes through the vertex and bisects the side that is opposite the vertex. So if I were to draw a median, I could start at B and it would go down to this side AC, and what it does is it splits AC in half. Okay? And I could do the same thing with angle C. I want it to split side AB in half, so it would be drawn somewhere like that, so that this side was equal to this side. And then I could do the same thing from angle A, and it's going to split side BC in half, so these two are the same. And what I want you to notice is that the medians of a triangle share a common point of intersection. And it's not going to matter what triangle I draw this in. If I were to draw my medians over here, again, they're going to share a point of intersection. And if I draw them in this one, they're going to share a point of intersection. So every single time the medians are going to intersect, that point of intersection right here is called the centroid. So the point of intersection is the centroid. So for this triangle, this would be my centroid. Okay, it's that point of intersection. So you have a question over the side that says, where will the centroid fall? So the centroid will always fall inside the triangles. It doesn't matter what kind of triangles they are, acute, isosceles, obtuse, right triangles, it does not matter. They will always fall inside. You also need to write down that a centroid is also known as the center of gravity. Okay, it's also known as the center of gravity. Now, on the actual notes that you have in front of you, there's a little squiggly line drawn here. The reason I drew that is because everything in this section, what you are looking at right now on my screen, every single thing here has to do with medians. So if they ask you about centroids, they're talking about medians. If they talk about medians, they're talking about centroids. All of these things have to do with one another. So moving on to the next section, it was an altitude. So altitudes are lines or segments through a vertex and perpendicular to the line containing the opposite side. So looking at these particular triangles, what the altitudes do is they go from the vertex and they go straight down to the other side so that they're perpendicular. So I could draw one from A, and it would be perpendicular here. And I can draw one from C, and it would be perpendicular here. And notice that these do not bisect the sides. They don't split them in half. The big thing is they are perpendicular. They do share a common point of intersection. They share a common point of intersection, and that point is called the orthocenter. Okay, so this point right here would be the orthocenter. And there's a couple questions I told you to look at the definitions for. So the first question says, where will the orthocenter fall? The orthocenter is always falls inside an acute. It is outside an obtuse, and for a right triangle, the orthocenter lies at the vertex of the right angle. So the word vertex goes in that last blank there, and it's always inside an acute and outside an obtuse. So you're going to have a question on your quiz that's going to say which of these is always inside. Well, the orthocenter is not always inside. It's inside if it's an acute, but it's not inside otherwise. So again, we have a squiggle line at the end of this, and that means that everything in this section right here has to do with altitudes. Everything here. So orthocenters and altitudes go together. All right, angle bisectors of a triangle share a common point of intersection. What angle bisectors do is they bisect the angles. So if you'll notice here I have this triangle and it split this angle into each piece is 32. This line split each piece into 37. And this line split each piece into 21. Okay, where angle bisectors lie, where they meet, because again they intersect just like everything else has, they intersect at this point here, which is called the incenter. Okay, this point is called the incenter. There are three things you need to know about the incenter. The first thing you need to know is that it's equidistant from all three sides. Okay, what that means, I'm going to draw this in pink here, is that this distance, and this distance is the same. Okay, the second thing you need to know is it's where the angle bisectors meet. And the third thing you need to know is it is always inside. No matter what, it is always inside. So everything in this section right here has to do with angle bisectors. So if you're talking about incenters, you're talking about angle bisectors, and vice versa. Last thing is perpendicular bisectors. Perpendicular bisectors share a common point of intersection as well. And what perpendicular bisectors do is they're perpendicular and they bisect the other side. So they split this side in half, and they split this side in half, and they split this side in half. Where they meet is called the circumcenter. Where the point where they meet is called the circumcenter. So when you're talking about circumcenters, you're talking about perpendicular bisectors. Now you had to know a couple questions. You had to answer a couple things in vocabulary. Look at the definition. So the first thing you need to know about circumcenters is that they're equal distance from the vertex. So that means the distance from here to here is the same as the distance from here to here is the same as the distance from there to there. The second thing you need to know is it's where the perpendicular bisectors intersect. And the third thing you need to know is that it's always inside and acute. It is outside and obtuse. And it's on the hypotenuse of a right triangle. So if you had a right triangle, your perpendicular bisectors would be here, here, and here. These are all three of these lines are perpendicular line they intersected at, and if you notice they all meet here. So this would be my circumcenter.